Hello students. So today let us take the next heart in the next series, which is heart of crocodile. Now here when we say crocodile, it also means the alligator as well as the caiman. This is true not only for this but for the entire group. We want to first of all write down the salient or the important features that distinguish the heart of the crocodile. One is that the heart is four-chambered. Remember that crocodile is a reptile, but the heart is completely divided into four chambers. The ventricle is completely divided into four chambers. But in all other reptiles, ventricle incompletely divided. The ventricle is incompletely divided, and therefore it is around 3.5 chambers. Sinus venosus, which was prominent in amphibians, reduced in reptiles, now completely disappears, absent. And instead this gets incorporated in right auricle as pacemaker. The ventricle is largely made up of compact myocardium. This is the left auricle. This is the left ventricle. The right auricle, right ventricle, myocardium. Now you can see that from the left ventricle is arising this red colored tube which is arising over here. Okay, this is the aorta, and it is moving towards the right side. Okay, since it is moving towards the right side, we call it as right aorta or right systemic arch, and this one is called as the left aorta or the left systemic arch. Which is coming from the right ventricle. Also coming from the right ventricle will be this tube, this outgoing tube, will be the pulmonary artery. It is going towards the lungs. So here we have said that the ventricle has got a compact myocardium. Ventricle is completely divided into two parts. There will be right and left ventricles. Okay. From right ventricle emerges two tubes or two outgoing vessels, a pulmonary artery which is going to the lungs, and B, there is an aorta. Okay, but this aorta is going to the left side, so this is called as left aorta, or it is called as left systemic arch. You see, from the right ventricle emerges the left aorta. From the left ventricle emerges right aorta, or right systemic arch. But very important feature over here, right and left systemic arches are separated but there is possibility of mixing of blood because of two features. So take a look at the diagram. At this point where the right systemic arch and the left systemic arch just emerge out, there is something called as foramen of Panizza. So where is this foramen of Panizza? Just when the right and left systemic arches emerge out. So we will mark it here. This is the foramen of Panizza. Look at the diagram once again. On your left side, from the ventricle's base, we are seeing blue colored tube arising, and that is going towards this side. So we call it as a left systemic arch. Remember that from the right ventricle emerges left systemic arch, and from the left ventricle red colored tube is emerging right systemic arch. When they emerge out of the heart itself, there is a small opening between the two and they are interconnected. This is called as the foramen of Panizza. This is first one. B, just take these blue and red colored tubes, that means the left systemic arch and the right systemic arch, and see where they are coming down. When they come down, they again join over here. This is called as anastomosis. This is the anastomosis which is in the abdomen. So this is the second feature of the heart of crocodile, which is very important. So there is mixing of blood at the foramen of Panizza and at the anastomosis. From right ventricle also emerges pulmonary artery which will go to lungs. At the base of this pulmonary artery is a special cog valve. That can seal opening completely. So where will the cog valve be? At this point is cog valve. This is the third important feature. First feature important is foramen of Panizza. Second important feature anastomosis. Third important feature cog valve. So where is the cog valve? Cog valve is just like a valve at the base of this pulmonary artery which seals it up. What is the meaning of cog? A cog looks something like this. So these are nodules of connective tissue. So this part is actually like a gear, and it goes and fits into the pulmonary valve very firmly. Now let us see the conditions. Okay, let us see the conditions. That is three conditions. So when when crocodile is at rest, so when the crocodile is at rest, deoxygenated blood from inferior and superior vena cava. So we will write over here from vena cava. Enter right ventricle, and from there they get partly divided. Some of it will go into pulmonary artery, and some of the blood will go into left systemic arch, which is actually O2 poor blood or deoxygenated blood into the digestive system. But left ventricle is receiving O2 blood, which will go into right systemic arch, and it goes into the brain. This is the normal condition, or in any other mammal also the same procedure will take place. So let us consider what happens when crocodiles are active on land. So when they are active on land, the lungs are active, therefore more blood flows to the heart from lungs. So when we say that more blood flows to the heart, where will it come into? It will come into left ventricle. Through the pulmonary vein. So blood is coming into the heart through pulmonary vein into left atrium. From left atrium it comes into left ventricle. So the left ventricle now has got more blood. Therefore pressure in left ventricle is greater than pressure in right ventricle. Therefore blood flows primarily into from the left ventricle into right systemic arch and left systemic arch. How? Through the foramen of Panizza. And secondly, through anastomosis. So this is A and this is B. So you see, even if it goes from left ventricle into the left systemic arch, the input of this blood is through the left ventricle. Normally, blood from left ventricle will go into right systemic arch, but it also is going into left systemic arch through foramen of Panizza. And also through the anastomosis, same blood is being circulated. Therefore, most organs get oxygenated blood, and hence what is the situation in right ventricle? Naturally, in right ventricle, as usual and as is normal, there is deoxygenated blood. This deoxygenated blood is forced into pulmonary artery. Why? One reason is that cog valve is open. Cog valve is open and blood is already going into left systemic arch from the left ventricle, and therefore blood is forced into the pulmonary artery. All blood is forced into lungs, and naturally the cycle continues because all the blood is forced into the lungs rather than going into the systemic arch, and from the lungs back into the heart. More and more blood will keep coming and it is getting circulated. So the important feature is that the cog valve is open, and because of that blood goes into the lungs, and because the pressure in left ventricle is more than pressure in right ventricle, from the left ventricle the oxygenated blood is going through right and left systemic arches. So most organs will get oxygenated blood. This is when crocodiles are active on land. Now the third condition, crocs are in water. So they are forced to go underwater. Then what happens? Or they are going in underwater. So when they are going underwater, the lungs will stop, isn't it? Or there should be no air that is entering at that time into the lungs because it does not have gills. Therefore water will enter into the lungs at that time. It does not want that situation. Therefore pulmonary circuit stops. Okay, pulmonary circuit will stop at that time because this is a land animal and it has got lungs, and therefore this pulmonary circuit underwater will stop. Now here we have to remember that once this pulmonary circuit stops, therefore less blood comes from lungs to heart, or almost it will stop. It will almost stop. At this time, in the right ventricle, the cog valve is sealed. Now, where is this cog valve? This cog valve is at the opening of the pulmonary artery. That means the one that is going to the heart, that is blocked. Now, if this is sealed, hence blood in right ventricle moves into both left and right systemic arches. Now this blood is poor in oxygen, almost you can say deoxygenated blood. So this poor in oxygen blood or less oxygen blood is moving into both right and left systemic arches. This is an adaptation at that time. So what happens inside the crocodile? In crocodile, because it is what we should remember over here. Crocs are cold-blooded, or we use the word poikilotherm. So they are inactive underwater. So their requirement for O2 is decreases. Metabolic rate decreases. So all these things are related. They are cold-blooded at that time, they are inactive underwater, their requirement for oxygen is low, and their metabolic rate is also low. And therefore, even when blood contains less oxygen, this same oxygen poor blood can move throughout the body into both right and left systemic arches. This is through the same things. A foramen of Panizza and B through anastomosis. So in other words, blood from right ventricle is forced into left and right systemic arches, isn't it? That means to both the sides. So this is called as right to left shunt, SHUNT. Okay. Now remember that the crocodiles can remain in underwater for about 2 hours or so. So for a long time they can remain underwater, and that is because of this adaptation, that in right ventricle the cog valve is sealed and therefore no blood goes into the lungs, and this oxygen poor blood will move throughout the body. But this is okay because the crocodiles are cold-blooded and their metabolic rate is less. So in this way, the heart of the crocodile is so designed in order to survive under both conditions, underwater also and active also on the land. So with that, this is Professor Ravindranath signing off. Thank you.